Okay, in this video we're going to go over all the answers to the questions and how we got them. So on our very first questions, we needed to determine the number of moles of oxygen atoms. So if I have 0.05, come on, let me write on the screen, 0.05 moles, but I have 6 oxygen atoms per mole of magnesium nitrate, then I would have 0.3 moles of oxygen atoms. For the next one, I would have 0.05 times 4, or 0.2. The next one, I would have 0.1 times 1, so I would have 0.1 moles. And for the last one, I would have 0.1 times 2, so I would have 0.2 moles. So you should have, for this one, paid for your correct answer. All right, the next one. This one was a pretty easy one. You should have definitely just picked A as your correct answer, knowing that a subatomic orbital S has a spherical or circular shape. So we'll go on to the next one. The next one was one of our exceptions, and it was chromium. And so you had to be able to recognize what was the ground state or the lowest energy configuration for the electrons. And so you should have picked the one that had one electron stolen from the S and added into the D. Remember, this is one of our exceptions. The other exception was copper, and you're going to see that later in the test. All right, question number 4. This one is asking for bismuth. So you go find bismuth. It is located on the bismuth is located on the 6th period. Okay, so that all automatically means that it has 6 energy levels, so we get to cross off the ones with 5 energy levels. And it is located in group number 15, which means that it also has a 5A, which means 5 valence. Okay, so you should have picked energy level 6 and 5 valence for your correct answer there. All right, let's go ahead and move ourselves along. So this one relied on you remembering that to emit visible light, it must be releasing energy. And for releasing energy, we must be moving from a higher energy level to a low energy level. When you release energy, your energy goes down. So that means that moving up will not work. Okay, and moving up will not work. So that either leaves 2 to 1 or 3 to 2. And for it to be a hydrogen atom emission, we did learn that it must be only down to the 2nd energy level. So there's that one. Okay, so then on number 6, which series represents atoms in order of decreasing atomic radius? So first I have magnesium, which is on the 3rd energy level, and then I have beryllium, carbon, and nitrogen all on the 2nd energy level. So decreasing order means start from the biggest, so my magnesium is going to be the largest. That means I get to cross off A and C. Then I have to put the beryllium, carbon, and nitrogen in order by increasing numbers of protons. So beryllium has 4, carbon has 6, nitrogen has 7. So in order of decreasing atomic radius, that would be beryllium, carbon, and nitrogen. So your correct answer should have been D in this case. All right, number 7, how does a lithium atom form the most stable ion? So you go look up lithium and you find out that it has a 1A over the top of the alkali metals group. And so when you find that out, then you also know that it has 1 valence. So it is going to be most likely losing its 1 valence. So it will not gain, it will most likely lose electrons. And so then if it started with 3 protons, 3 electrons, it loses 1 electron to go down to 2 electrons. Now it has an overall positive charge, so this makes a positive ion. Okay. Number 8, which trends are correct across period 3? We did learn about, we actually had notes on all of these. We did spend time talking about atomic radius and first ionization energy, but you might have wondered about this melting point. And while that was in your notes, you might not have spent some time learning about it. So let's see if we can talk about Na all the way to Cl. Well, let's talk about states of matter all the way across the periodic table. sodium, magnesium, aluminum, silicon, phosphorus, and sulfur are all going to be solids, but when you get to chlorine, chlorine is existing at room temperature as a gas. So that would not mean that melting point is increasing. That would instead mean that melting point decreases. So instead, our correct answer would be 1 and 3 only. All right. So our next one, number 9. Deduce the full electron configuration of Fe2+. Now this is going to require that you do Fe2+, not Fe. Most of you, if you got it wrong, you did it for Fe. So if you got it wrong, you wrote 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d6. Okay, so cool. But you did not answer for Fe2+, you just answered for Fe. For Fe2+, you have to take off the last 2 electrons, which are the outermost electrons. So you should have written 1s2, 2s2, 2p6, 3s2, 3p6, 3d6. Should have been your correct answer on that one. Okay, our next question. State the nuclear symbol notation for iron 54. Okay, so what you had to know, and this was part of your reading, this is also part of sophomore level chemistry. You needed to remember that the A is the mass number, and that was given right there, and that Z was simply the atomic number. So you had to look up the atomic number and the symbol for iron, so you should have had 54 over 26 Fe as your correct answer here. All right. Next one required that you do some calculation. So let's take a look at what that really means here. In this case, there were 2 points associated with this, and you had to not only do the calculation, but it says calculate the relative atomic mass of the atomic mass. So here we go. So we're going to take the mass, 54, times the percent, 0.0584, whoops, 4, plus the mass, 56, times 0.9168, plus the mass, 57, times 0.0217, plus 58 times 0.0031. And if you do all of that, you should have rounded to 2 decimal places and gotten the answer as 55.91. You only got 1 point if you wrote 0.911. So it did say to 2 decimal places. So if you just looked at the periodic table and read the answer off the periodic table, you wrote 55.85, and you did not receive any credit for that because you did not do the calculation and you did not, so you did not get the correct answer. Okay. Okay, so the next part is what we were doing the redox reaction. And the first part of the redox reaction is saying iron 2 can be converted to iron 3. So there is our first change. We have iron 2 being converted to iron 3. And I can see that that is the loss of 1 electron, so that is oxidation. That means the other reaction has got to be our reduction, and this is saying that hydroxide ions inside iron 2 hydroxide can be gotten by using hydrogen peroxide. So that means we're going to use hydrogen peroxide to form hydroxide ions. And you might be going, well, I didn't know hydroxide ions. You could have uncrisscrossed these charges to figure out that hydroxide was 1 minus. Okay, so let's balance this one. To do that, I need a 2 right here. And then to be able to balance out my electrons, I'm going to need 2 electrons here. That means this equation is going to have to be multiplied by 2. So we end up with 2 Fe plus H2O2 yields 2 Fe3 plus 2 OH minus. And that is our completed balanced redox reaction. So there you go. That is the result there. Okay. This next part, we had to explain the trend in atomic radius and compare it to that of ionic radius. So compare and explain the trends. Okay, so for this, we would say that the atomic radius decreases across the period because effective nuclear charge is increasing as protons increase. All right. Now, this is similar to the trend for the positive ions as protons increase. However, when the ions become negative, and that's with phosphorus 3 minus as our, phosphorus 3 minus as our first example. Now, the proton to electron ratio decreases, and there is greater electron repulsions. So the ion radius increases. That was a lot to write. It was worth 4 points. All right, our next part is talking about the describing the electron arrangement and properties of the elements. And first we're going to talk about what is the property used to arrange the elements on the periodic table. So we're going to answer that one by saying atomic number. You could have also said number of protons. Okay, so for the next one, outline 2 reasons why electron negativity increases across period 3. First reason, protons are increasing. And the second reason was that the atomic radius is decreasing. Okay. You could have also said greater effective nuclear charge. The final thing was we needed to talk about one reason why noble gases are not assigned electron negativity values. They are already full of electrons, or you could say more formally that they have full valence shells. Okay. The next question worth 6 points. First, we had to define the term first ionization energy. The formal definition is the energy required to remove 1 mole of electrons from 1 mole of gaseous atoms. I was being very, very easy on that grading. If you got points for that and you didn't have all the parts, lucky you. Then we have to explain the general increasing trend in first ionization energies, and that needs 2 points, so we need 2 parts. So the ionization energy is increasing because the effective nuclear charge is increasing due to protons being added on the same energy level. Okay. The last part. Explain why there is a difference in general trend between phosphorus and sulfur. Sulfur has less ionization energy because electrons are paired in a orbital providing more electron repulsions. Okay. Next. All right, we have to finish our last two. We're going to finish with copper 1 ion. And so the copper, if we just do regular old copper, this is also another of our exceptions. So we had copper, which should be, if it's just plain old copper, we should be showing this as 4s1 3d10. However, we're having to do the copper 1 plus ion, so you should show this as 1s2. Means that that electron is taken away, 2s2, 2p6, 3s2, 3p6, and we should end with 3d10, just like that. Okay. If you didn't get that one right, it's because you took off the wrong electron or forgot that you were supposed to take off an electron at all. Okay, our final question. The student heated a sample, and here's the following information. We want to know what is X. And so the first thing we need to do is that means we're finding the number of moles of water. So the first thing we need to do is find out the mass of the hydrate. This is going to be for our hydrate. So I'm going to take the mass of the whole thing minus the mass of the crucible. And when I do that math, I get 18.360 minus 16.221, and I get 2.139 grams. Then I want to know the mass of the anhydrate. So that is going to be 17.917 minus 16.221. 17.917 minus 16.221, and that gives me 1.696 grams. Then I want to know the mass of the water. So subtracting those two will give me the mass of the water, 2.139 minus 1.696, and that gives me the mass of the water at 0.443 grams. Next, I want to know moles of the water. And so the moles of the water are going to be gotten by taking 0.443 grams and dividing that by the molar mass of the water, which gives me 0.024584. And yes, there were 5 significant figures in this part of the calculation, so there should be 5 significant figures for the moles. The next thing I want to know is the moles of the anhydrous, which is just the CuCl2. So I have grams of the anhydrous of 1.696 grams, and I'm going to divide it by that molar mass. And that molar mass is 1 copper plus 2 chlorines. And so my molar mass for that is 134.45 of the anhydrous. So I end up with 1.696 divided by 134.45, and I get for my moles of my anhydrous, copper 2 chloride, 0.012614. Okay, so now I need to know X. And to get X, I am going to take moles of water, 0.024584. I'm going to divide it by the smallest, which is 0.012614, And when I do this, I get 1.95, which is very similar to 2. So that means that this is CuCl2.2H2O. Okay, so if X is 2, then I need to actually calculate the concentration. All right, so to calculate the concentration, I'm going to do 15 grams divided by the molar mass of that hydrate, which is 1 copper plus 2 chlorines plus 2 water. And that molar mass will come out to 170.49. Now, to make this calculate into molarity, which is in moles DM-3, I need to divide by 0.1, which is actually 0.1000. That's 4 significant figures. And so then I'm going to, overall calculation, 15 divided by 170.49 divided by 0.1 gives me 0.87. Actually, we're going to round to 2 significant figures because 15 was 2 significant figures, and that is the molarity of the solution. So you had 2 answers here. Thank you, everybody.